like are about this kind of story. So I'm thinking, I mean, since it's on a bigger discussion, then why don't we just make this as a storytelling? So open source, closed source, you all heard about that. And Microsoft is closed source, right? We have to get license, subscribe. But there are lots of open source tools, like, can any of you give example open source?
Right.
Sorry?
Right.
For
Python, yes.
for models like
Yeah, for anything, like
DeepSeek R1 model, so
Yeah.
it's available.
Yeah, a lot. Like GitHub.
Yeah.
If you go to GitHub or Hugging Face, you can download lots of libraries, or source code, or even software.
Even someone can contribute it.
Exactly. And that's the most beautiful part of open source, because everybody's contributing their part, and make that free and it can be copied and used by others. That's really accelerate the technology is moving. So I would say for the last 20 years, AI actually is achieved by open source. Ubuntu is open source a platform. So which one is good? Like OpenAI in the beginning, it's called open, but then it became to be very close because nobody can see their, like, you know, how they did their model. What is exactly their algorithm? Where is their model? Can I download their model? No, there's no way for doing that. Rather than that, you have to pay like sometimes $20 per month or $200 per month to get their service. So it became to be a strictly closed approach. But there's a competition between those two directions. Which one is better, or which one is safer? So our story gonna start with that. So we're trying to framing the debate in the evolution of large language model at the beginning. So that's a plot. I can introduce some background, like what I have said, and then I give some context. You know, like some big giants, they prefer using OpenAI's solution, but other small companies, they really take care about their cost. They prefer open source. Then the main question you can ask to your audience is that, how are open source and closed source approaches shaping the evolution of AI? And what does this mean for innovation and accessibility? Of course, accessibility means you have access to it, but you don't have free access. And is this closed approach is really not good for innovation? I'm not too sure. So data overview, you can prepare something at this moment. So you can go out to GitHub, you can do your analytics over there. You can check your comments, what is the best post for this month. Like I can see some tools published over there. Just publish 1 week, they get like 100,000 stars. So that's very, very interesting open source project. And you can, again, you can of course finally, rely on Tableau or PomPom to do that kind of data analysis. And the visual elements, you can try some like split screen infographic display. Collect those logos, for those different approaches. Like logos for OpenAI, for Meta's Llama, for DeepSeek, open source community, and you can also generate some key milestones, like probably 3 or 2 years ago, one GPT just released, like what is being changed since then for 800 days. Like there's some miles, I can see that. So that can be like a very interesting background we can start. And then we're trying to introduce some tension. So the tension is that we analyze those publication trends and GitHub. for those open source large language models versus those commercial ones. And we also find some benchmarks. So clearly, we can identify that open source project, it's really growing rapidly. Then what about the closed one? The closed one actually, they attract more funding. Like, I think OpenAI recently, the leader says we're going to get more than another, say, 700, $30 billion. They want to enforce on their research. And they're still the leader, like the OpenAI, I think they released their latest model called O3 Mini. I played that during the weekend. It's like lightning fast. And it's very accurate. So they're still the leader, but the open source approach are trying to catch it up with minimized cost. So the key observation is that open source is growing fast, and in contrast, the closed one, they're the one of the most performers regarding their models accuracy, the performance, and they also introduce lots of metrics to measure how good their models are. So metrics is like, you don't have to understand what this really mean. But basically I can give you some example. So those organizations like Google or OpenAI, they're trying to design their model to be good with all the domains, from math to physics to biologies or art or reasoning, all those things. So for each of the domain, they develop some benchmark. So for instance, hey, this month OpenAI's ChatGPT achieved like 80% of the benchmark as precision, for coding. Maybe even better. What I heard is that the OpenAI's latest O3 Mini can do the coding like better than almost every engineer right now, almost every. So that's a benchmark they have developed to measure how good those models are. And then what you can put for your Tableau dashboard or worksheet, it's like you can put some line charts as a comparison between the GitHub and the closed source models. So this is a very abstract. But that's a point that you can brew it up. So it's actually happening, like last week, right? I'm not saying I can predict that, but I can see that kind of trend like 2 years ago. So since OpenAI released their ChatGPT, the open source communities like Meta, they have a project, they call it Llama. So Llama is quite a nice open source large language model. I use it, I download it to my computer. I'm trying to compare its performance and ChatGPT. And I can see that it's very slow, and sometimes it gives me very long answers. But they keep going. They're inspiring other large language model, which can be built up based on that. So it's keep going until you might heard about that. There's French company, and they released some open source model called Mistral. So Mistral is very powerful model, small, but you can install on your computer, and actually even outperforming Llama. So all those are good models, and I can feel like, someday they're going to be happening. You're going to find something going to be as good as OpenAI, but you spend like much less cost or even free. And that's the moment what happened 3 weeks ago. So when this company, it's called Higher Flyer, and I mean, I'm sure I don't want to bring so much controversial discussion about this company, but the point is that that company released a large language model called DeepSeek, which is I've been testing, and I find out as coding, as mathematical reasoning, is as good as OpenAI's model, and it's free. So that's a moment, that's a breakthrough. So we thought open source going to be always like lagging behind because there's no big capital invested, but now it's an exciting moment. It's performing as good as a closed source approach. So what could be the impact? The impact is that kind of milestone event going to trigger a lot of conversation, debates on how we're going to decommoditize AI. And how we're going to carry on innovation. So in your PPT slide or dashboard, you can put some chart showing the memory performance gap. Like maybe 2 years ago, the gap between two directions is like probably 30%. But right now, it's maybe 1 or 2% gap as their performance. So that's a big shock. I mean, that big shock is like spreading from the data to technology. It's everywhere. So comparison in this case does show something very interesting. So that's a big moment. And then you're going to move a little bit down from your the most exciting moment. So you're going to analyze the ripple effects. So what's going to be the aftermath of open source breakthrough? So you can do some further analysis, like research part, researchers, and even capitals. A more community project going to be like trigger a lot to go to that direction because we can see, oh, that's light. We see it's being successful. Then it's worthwhile to invest more to do that. And we don't mind that to share that with everyone. And that breakthrough also going to trigger lots of collaboration among academia, industry, and almost everyone. So even those closed approach, they might also have to shift a little bit as well. You know, the Microsoft and NVIDIA, I mean, in the beginning, they were a little bit like suspicious about DeepSeek, but just 3 days later, Microsoft declared that let's just plug it into our cloud. So it's already there. And NVIDIA as well. So they have DeepSeek as an option, installing their cloud. So that's a proof, right? That's a proof that, because why? Because they think, hey, it's saving us a lot of cost. Forget about those politics, ideology. It's saving me a lot of money, so why not? So second findings is that some companies, they're going to take some hybrid models, like Amazon, like Microsoft. So Microsoft is 100% license-based, but in their cloud service, they also integrate with those open source because it saves money for them. So visualization for this part, you can put bar charts, comparing the research output and community engagement before and after. And you can also have like a flow chart of the breakthroughs impact on the collaboration and strategies. So all those things, it looks like a hype factory. But I think it's happening, right? Probably in 2 or 2 months, this is going to be the past. But this, I just want to tell you that this is what's right now is happening. So the last part, the end. the resolution. You are going to give your audience that what is the key takeaways and recommendations. You can say something like, for researchers, developers, come on, let's just take the open source collaboration, because it's fast, it's good quality. And what about the industry leaders? Yeah, they can have a hybrid, little mind to use open source model as well. And what about the policymakers? They do need create some guidelines for transparency, ethic AI, and balanced growth. So ethic thing of AI is another big problem right now, because imagine everybody gonna get open source model, right? And they're gonna do something based on that. And you don't know what thing they can do. It could be something dangerous, you don't know. It's shared to everyone, as long as we're doing good things. But if somebody's gonna use that to develop some like military robots, and military robots is driven by a decision making, and they can make decisions like in a second with these models. Because this model actually, you probably heard that it helps you to do some operation from your computer. If you can do something with your computer, then the large language model can also help the robots to do something. Because basically it's another operation system. So what going to be that stuff? So that's about ethics. So finally, you can have some icons representing the collaboration, between those two directions. But there's something else, like you could tell audience that the competition between open source and closed source approach isn't just a battle. It's a dynamic interplay. We don't know what's going to happen tomorrow. There might be another shift. You never know. But so that's going to be lots of dynamics. So we need to think about how different models of those innovations can coexist and they even complement each other. So as you can see, there are five stages you can put. And in Tableau, you already can build out a dashboard, right? And then there's another function, click, you can create a story. So for a story, it's part you can draw a dashboard into that as a single component, like this one. I'm not saying you have to get like a 5 dashboard, but that's something similar. So you have like one dashboard for background introduction by analyzing those data in the background, and then you have a second dashboard for giving some like tension. And the third dashboard is about the aha moment, and and the fourth and five for each of them. You can also present that as a PPT slides. Like finally, when you present, dashboard might not be the most convenient stuff if you want to stand there and talk. So slides are still a good way, but in that case, you're going to need some slides, to simulate this procedure. Let me just show you where the part you can create the story with Tableau, but we're not going. So this is the story, and you can, for instance, if you already have, the left part, it can be a worksheet or it can be a dashboard. So you can just draw it. Let's say this is the stage of the introduction, and you can give a name. You could give more, right? And you can just create a lot like that. So next one gonna be rising action, and you can just move another dashboard somewhere. So this is a way you can render your story there. It's quite simple, but you can do the similar thing with your slides. I'm going to show you something else. So this is the major food I wanted you to taste today. I heard from some of you that you have learned actually quite complex skills from previous semester. It's about how can we put those analytics functions is Tableau. But to be honest, so far, all those predictive tools provided by Tableau, I could say that's a little bit naive. I'm sorry to be honest, it's a little bit naive. And compared to the realistic application, that is too simple. What I'm gonna show for the next stage, you're gonna say how complicated it is. I mean, what is the point for being sophisticated? We don't want that to be sophisticated, but the thing is, the reality is always very challenging. And we have to go through so many steps, which makes that looks like sophisticated. So a big question here is that, can we use Tableau to leverage historical data, statistical algorithm, and even machine learning techniques to forecast the future events or trends? Is that possible? Let's find it out. I have to, when there's something I show you, I want you to observe as evidence. So I also heard from some of you that you have learned trend line. Right? So let's have a simple review. So this paragraph, this picture is still about the superstores, the global superstore sales. And I have a regression line there to fit the trend of that data. How good it is? Does that model fit it very well? How good is it? Do you have any measures? What is the evidence support you to declare to your audience that, hey, this is good, this fit is good, or it's poor, or it's just okay? So there's a way you can check out from Tableau when you do trend line. And you can check it out from those models over there. And I would have asked, I would have a question, for you is, what are those two things? R squared and p-value. You have learned that from the previous semester, right? Or you just simply find, drag a line. Do you check those numbers? I know this is all of this is data visualization, but you definitely learn some math from other course, which should support, that's going to be the interaction between those courses, right? For me, I do look up those two numbers. R squared is number to measure how well your model fits the curve. If this line is your prediction model, those zigzags are real data. And R squared actually tells you how much or how perfect your model can forecast the trend. The more the better, like it's actually, the perfect one going to be 1. It's a number between 0 and 1. There's some like mathematic formula how you can get R squared. You can check that later on, but that's not our main stuff here. But that's an indicator you can check. And I always use that indicator to convince my audience that hey, this is a good model. This is a decent predictive thing because it achieved R squared so high, like 84%. So whenever you get R squares, like this is okay actually. This is just okay. The better score gonna be 70%. And even better, more distant score gonna be 80%. If it's hard to understand what is R squared, you can simply understand that in this way. I'm sure everyone understands correlation, right? Correlation. So you measure the structure similarity between 2 variables. Like this could be one variable. Let's call that your estimation. And this is actual variable. So what's the relationship between those 2 variables? Normally, when you achieve correlation score, like 90%, that's a good score. That's a really nice score because you can see when the X is moving up, the Y is also moving up. Like basically those 2 variables are moving up and down at the same time. So that's why we call that they have very, very good structural similarity. So R squared, which basically means the power of the correlations. So 0.9 times 0.9, that's 0.8. So you can basically get from that number, you can break that down into a correlation. So that means 90% of correlation between your estimated value and the actual value. But this one, no. This one is about like less than 8% for the correlation. So this number is very important. I'm going to show you later on as well. For a real project we have done, we also use that as an indicator. Now, what about the p-value? So what exactly is p-value? What can p-value tell us about? So p-value is something to help you to measure the statistic significance. I know this is kind of a headache, it's about math. But you can simply regard it that the lower this value is, the more reliable your model is. So again, this value actually is between 0 and 1. Like for really good models, it gets like this one. This is quite good. But normally the scientists or researchers, what they accept, they would accept 5% as a p-value. So whenever the model achieving less than 5%, that's accepted. If it's more than 5, accept. More than 5% of 5%, they're saying, hey, your model might not be that reliable. So that's basically 2 indicators. I really want you to pay more attention because when you stay there, you're trying to tell your audience, this is not just about graph, but also about statistics. I can show that it's reliable to prove that your model is good. So do you want to try this one, or you already tried the trend lines? Or you want to practice a little bit? You can skip that. You can go to the next one. So there might be something new to you. It's forecast. So forecast is something different from the trend lines. So what does forecast do? So the forecast is like, based on some time theory data. And it's also going to model what could be the trend, or what's going to be the value for the future. Like in this case, this is a historical data from 2011 to 2015. And I'm going to apply Tableau forecast model, and it's going to tell me that, hey, this is going to be what happened from 2015 to 2016. And that's just, trying to have you be familiar with this one. So let's, let me copy this file to you, and you can just open it up. I think it's still relying on the so as those two files are like moved into the Teams channel, please download that and open the Tableau file. I mean this one, predict and lattice. So I can show you the worksheet made for sale. Before you can do like, for this, I have columns is all the date and sales as the rows. And then I can do some trend line, right? There are like so many different options. And for linear, that's a very simple, straightforward. For polynomial, you can decide how many access you have. And when I move my mouse there, you can see, right? You can see the formula of this trend line. It's telling you that cells can be represented as a linear combination of the month. And the p-value is quite small, and r squared is 6%. It's okay. And you can try something else. You can try like exponential, linear, or polynomial. more details of that regression. Okay? You already learned that from last semester, right? But I want you to check this one. So if you can create the profit forecast, I already moved data out there. So again, all those data are time theory based. When we're mentioning like forecasting, predictive modeling, most of the cases are relevant to this time. So we call it time theory data. Let's move order data on the top. We just want to look at months because days are too many. And we want forecast the profit. And what you can do is you can, on your analysis panel here, you can join forecast. That's too simple, right? I mean, you still want to know what's going on behind that. So if you want to know more details, you can just right click on your forecasting part and you go down to forecast and you can go for describe the forecast. And you can also change your forecasting model by clicking the forecast options. So here is actually more interesting. It's more for you to revise your forecasting model. So here is the automatic, that's before that.
Sorry, can you show again?
How many minutes do we have?
Show again. Can you show again?
Oh, hello. If you can move your and you go to focus, and you go to focus. So you can define your forecasting theory, like to be next to certain amount, or like exactly like 2 years, 5 years, maybe like try like 2 years to get from 2015 to 2017. And here actually is the most interesting part. I want you to know that, right? Because this actually is touching the algorithm of the forecasting models in top. I'll tell you more about that from the slides. So this model is very different from the trend line. The trend line is just X1. But this one, I think the researchers are quite smart for inventing this scenario. So I think his name is called Hot Winter. Like this algorithm is back to 1960s or 70s. And he thinks this time theory based data has relevance with those three things as factors. Level. The baseline value of the theories, like every month or 2 months, there's like a mean, I guess, as a level. So this kind of level are moving up. The second factor, the trend. Okay. The direction in which the theory is moving. Is going up or going down? Or like going up all the time, or going up only for some particular period. Which is about the third scenario, seasonality. So on Earth, we have 4 seasons. I mean, when we look through those time theory data, many of them have a seasonal behavior, like spring, winters behaviors are totally different. So the model are like supposed to catch those regularities. So those three things, winter, use those three things to forecast a number. So he invented a algorithm called exponential smoothing. So that's kind of like a time-related stuff. Basically, the next moment, so here, t plus 1, so that's the time. The next one is relevant with the previous one. And actually, it has more weight on the previous one than the one occurred like maybe 3 weeks ago, 3 years ago, which makes sense because yesterday's events probably contribute more things to today's events. So that's actually matching our common sense. But this is a very, very interesting, and it's actually being proved to be working very well. So if you can load those three factors into this algorithm, this is just like the single. You could have double and triple. So triple means your algorithm will cover level, trend, and seasonality. And finally, that gives you your model. So that's quite the concept. And you can play with that. So I'm gonna play here is that please go back to our that file. So if we can, I want to change this model by right click, forecast options. So automatic, which means the system already takes on the default. But if you want to go to customer, like defined by yourself, you can see here trend, addictive, season, multiplicative. You see all those things change. What does this mean? Addictive, which means the forecasting algorithm gonna take those three factors as adding. By adding them, so in the combination, it's going to be a plus relation between them. But if you specify also, but that is for the trend. But if you specify like multiplicative, which means you're going to time, your algorithm going to time the seasonalities. But what's exactly happening behind that, you really don't even know, because that's going to be something for the Tableau developers. But I want you to maybe practice a little bit here, maybe for 5 minutes. So for instance, years, you can try with that, like weeks is not working, that's good. You want to try, let's try now both. I want to see how the model behave. So that's 2 years. But did you find any problem for this approach?
You're just simply copy pasting the past trends. So
That's right.
the rate of change with the compared to previous ones. So like that, it is increasing.
Right. So it's quite time related. It seems to be only looking back the previous events. But there's another thing, like how about other factors? So all those things are maybe previous one, previous two. It's still about the variable itself. But how about other factors? Like, this is time, right? But if I think, this is about profit. What if profit is also driven by some factors like sales or orders? So that's a multivariable factors. So that model is not catching up that stuff. And there's another thing is, I don't find evaluation for this model. How good it is. I mean, sometimes there's no way you can estimate how good it is for forecasting future, but at least it should show me something for the historical data. Using that model, by forecasting back the historical data, how well it fits. Does it have like a p-value or or mean absolute error rate? Does it have it? No. So I mean, it's very intuitive, but mathematically not that strong enough. But that's quick and straightforward, and it can apply. And there's the one thing that Tableau is totally missing so far. Oh no, sorry, not this one, next one. I think Tableau is okay in this case. It can also help us to do clustering. So anyone can tell me that what's the difference between the forecasting and clustering or regression, or maybe regression. What's the difference between regression and clustering or classification?
I think regression is like a trend line, and cluster are like, specific points of data. They're
Right.
not like, there's no, they're not attached in a particular way, they're just like scattered points.
Right. Okay. That's right. So basically, cluster and classification, it's a similar. Which means there's a certain category as a group for those points, and it's discrete rather than continuous. Once it's continuous, like you have lots of number, and number could be like from 1 to endless, or decimals. Those are continuous. They are number. They are value based. So in that case, you need a regression model. But for classification model, your goals are very, very definite, which means you probably only have like 3 categories. Like I did, just give you an example. I did wild spices classification for parks. So my job is classify the image. Hey, this image is human being or deer or moose. You only have like a very fixed vocabulary. But for regression, the value could be anything. It's indefinite. It's values. But for clustering, that's a very specialized case, because clustering, it's not the supervised approach. It's like, in this case, I would use a term called self-organization approach. So imagine you have a lot of dots here. Like that's a sales of a superstore, a lot. And you want to classify, you want to cluster them automatically, but you don't know how to do that. But what you know is, hey, I just want to have like 7 clusters. Let's say how 7 clusters work. I want the data to be automatically categorized within 7 categories, and every category is a cluster. So that's something what Tableau can do. And I can give you another real example, like sometimes we need to segment the customer satisfaction. So we have some surveys for our customer to write down what's your feedback on our transport service. And we write their text as opinions. And it's hard for me to to read each of them and give a label for this as a feedback. What I'm supposed to do is leave the machine. I feel like I want like 10 topics. Can you do something to automatically classify or cluster this 100,000 surveys into only 10 categories or 10 clusters? An algorithm can do that. How? This is a way that behind the tableau. Again, I mean, I don't just want to show you like how tableau is working, you know, by dragging. I want to let you know there's some mathematics or there's some like data science, empirical lessons behind the tableau. So why tableau is doing that? So Tableau is clustering the data based on a method called k-means. I'm sure many of you have heard that before. And this is a very interesting illustration. So k-means, it's like in the beginning you have lots of points. You don't know where they belong. And you just randomly like toss up number, say, I want to cluster them into 4 clusters according to their self-organization similarity. You could name any number, like 7, 8, or 9. But what the algorithm does is that it's going to automatically set up some centroid. So this is going to be random selection procedure in the beginning for initialization. So you're going to randomly choose like 4 points anywhere and use each of the point as a centroid. That's just assuming that's a short centroid of some supposed to be cluster. And then the algorithm is going to calculate the distance between all the other points by using some Manhattan distance or Oakland distance, and the criterion is trying to minimize, like whenever a point, its distance to the centroid is minimized, and its distance to the other centroid is maximized. So the algorithm is repeat this procedure like many times. It could be like minutes, because you're gonna try each of the points, and then finally the algorithm gonna dive or gonna converge until it's achieved some point that no matter how you move, the centroid is not moving anymore. It's there. So k-means proves to be a very classic methodology as well, and it's straightforward. Like these days, if you try from your side, you write down k-means just as a Python algorithm. It's like 100 or 50 or 20 lines. You can achieve that algorithm. So it's very easy to be implemented, and that's a clustering algorithm behind Tableau. So we can do some exercise here.
So what was the red dot like that moving? What it's showing like? What is that red dot showing? What the mean of that red dot which is moving?
What does it mean?
The red dot is moving. Yeah. What is the meaning of that?
It's moving around because this is a centroid, right? So this red dots are centroid. So centroid is, you can think that as a very central point of a cluster. Like you can think that's a leader. It's most important point of a society, of a family, or of a human group. So we call that a centroid. So the function of the centroid. Centroid, yeah. So centroid, you can just forget about the centroid. You can just think of a center point. So the central point, the function of the central point is trying to have all the points that have very close distance from them. in that case, all the surrounding points gonna be recognized as members of this cluster. So center point
Got it.
going to be representative of that cluster. So that's it. And we're gonna have some very simple exercise. So if you can go back your Tableau, do you have this or not yet? This one? You have it? You have this? Yeah, okay. So, as I already have classes, I just remove that. So that's the very beginning. It's chaos, right? It's no categorize. I'm going to move cluster there. And default is like here, you can type 3, and you can type like 10. And you can also drag more variable. For instance, I want to say, I'll go back to data panel. I want to move the country there. So country can be a point line to cluster this point as well. So from trend line to forecast to clustering, Tableau covered all of that, right? But
Can you repeat the step, how we create the cluster like in Tableau?
okay. Yeah, let me know. That's good. Let me know that you are used to it in your time. So, so if you can go back your analytics panel, cluster, forecast, trend line are 3 things there. We have applied trend line and forecast, then you can drag cluster there. And you can make like, let's say, 100. That's too many.
So it's showing 50.
Yeah. I think there's some like, limitation. And my machines are really, I shouldn't try that one. And you can drag more, let's see. So clustering might be the easiest way to try, because the algorithm itself already covers everything. You don't have to specify. You only need to specify the number. So K means the K is the number of the cluster you want that algorithm to have. So K just like variable.
So this is the
Your
regression.
case
Sorry?
Your case then?
Yeah. Yeah.
So this is the regression thing, sir?
No, this is not regression.
Because there are numbers only, like it is categorized based on the numbers only.
Sorry?
It is based on the numbers only.
Yeah. But here, the number is for algorithm to calculate the distance between the center point.
Like how
Like-
these categories are different from each other, I'm asking.
Like, I'm gonna explain you right now. So let's say in this case, I can also do clustering. Let's see something different. Let's try clustering. Now, this time, you might see some simplicity. So every cluster, it's a band. It's a value band. So when that number or that point fell into that band,
Okay.
so in this case, like from 100 key to 200 key, that's the first cluster. Yeah.
So this is based on the different bands, like,
Yeah. Yeah.
got it.
So cluster, yeah, I mean, you have very meaningful question. So you're trying to understand what's output produced by cluster. It could be a discrete, a string, like what I mentioned before. It could be gear, could be an image. What's the label for that image? It could be, for this case, because it's a number, right? It have to come up with a range. Like in this case, the range is labeled. So it's from 100 key to 200 key. That's a category for those points. They're value based. So we're clear about this one. So we just move
Yes.
this. Do you want to have a break? Or you want to continue?
Yeah, yes.
Okay. Now this is more advanced. Back to our question, right? Using trend lines and forecast, you can see something quick. But in the real world applications, you want to model, like multiple, like one value based on multiple variables. You have to try something else. And this is the predictive tools provided by Tableau. It's called, unfortunately, it only have two functions. One is called model quantile. Another one is called model percentile. So we're gonna have some access on this as well. But before that, I have to tell you that what does those two functions really can provide us. So this function is trying to help us to predict the data that is only for a certain quantile. So quantile, which means, let's say, 50%. Okay? Rather than catching all those individual points, you are more interested in the median value of those points. So the median value can be calculated by 50%. So that's a point we call a quantile. And why they want to do that? Because they don't like outliers. And when you have some data, you have some data which is moving around always along your average value. And you also have something, sometimes it's strange. You can see that most of the points are like going up this way, but you see some scattered, very single points, which are much further away beyond the trend. We call them as outliers. And outliers does affect the modeling. If you don't know how to remove outliers, sometimes just several outliers can put your modeling into very poor performance. So what a top would take is, hey, let's try the major group. Forget about those strangers. Forget about those outliers. How? By use those like percentage or quantile based. Why? Let's just try those 50%. Let's try this median value, like 50, all these 50% of those values. So that's how the model quantile come out. So I'm gonna show you something and you can exercise. Okay. I'm not sure if it's already done on your side, but if you couldn't see that, let me know. Can you see that from your side? I mean, not from your eyes, from your desktop.
Yes.
Yeah, okay. So, to achieve this function, I have to calculate a field. So in this case, so let's start with the quantile. Okay? We have profit, we have time, and we need to calculate the field called this one. So this is logic. I already see, from your submission, you have applied something for calculating fields. Quite nice. So you're okay with that. But in this case, it's more. And there's some syntax, right? So if you can type or model, imagine like you don't have anything there, and you have to try like model, then the system will pop up and you only have two choices: model, quantile. Let me try something else. That was the beginning. And you want to create a quantile. And right there, if you type model, you only see those two things. Other things are not relevant. So you only see two models: percentile and quantile. And inside the quantile, the syntax to define your constraint or reduce a little bit of programming is like in this way. It's like you specify your model options, which is optional, you don't have to. But if you didn't specify anything, it's going to automatically try linear regression. Or you could try something with regularized linear regression or Gaussian process. In which scenario we want to use that? Here is the answers. You're going to get the slides, don't worry. If you couldn't catch this in class, you're going to have slides, which gives you more details in which scenario you should choose which model. So linear is when you think you need to model the relation between your variables are quite simple. Like you probably only have one predictor for forecasting your target. You know what is a predictor and target, right?
Target, variable?
Yeah, variable. So target is your forecasting or modeling target. So back in that to that slide, the sales is something you want to model, you want to predicate or forecast. We call that target. What is, you can call that Y, the Y value. But you also have some X. Y X is going to change, your Y value is going to change as well. So the X is a factor or something we call predictor. So you have target, you have predictor, and predictor don't have to be single. There can be multiple factors. It can be like weather, time, a lot of things. And then you specify your quantile number. So it's something between 0 and 1. So if you're interested in median value, that's going to be 50, like 0.5. And back to this one. Linear is quite simple. You think there's a very simple relation between your x and y. And regularized linear is that, oh, you have like more than 2 or more than 3 factors you have to consider about. And you probably have to try that one. You can always play around. And the last one is that your data, your x, y, the relationship between them, or you think it's non-linear, and you think it's quite complicated, but you're still sure they follow a normal distribution, you know, like a bell curve. And in that case, like you can try this one. So example here is that you are trying to forecast the temperature based on the time of year. So let's just do a quantile model and this one. So you already see that, right? You want to replicate that procedure? I mean, I can give you some minutes and right here. So for instance here, I try model, my model is RL. So that's regularized linear. And my number is like 30, 0.3. Here you might want to pay more attention is that your variable is date. But you want to focus on month. So this is data track. You have to use this function, and I use attribute because it's not a regular number. So if you have that one, I mean, you can try many times. Doesn't matter. Like you get some errors. That's just the syntax of the table, sometimes not very friendly. If you have a tiny error, it's going to tell you your calculation is invalid, and you have to figure it out by yourself rather than give you a very suggestive tips. I mean, I have pain sometimes from this. So this is a quantile. Let's say I want change to be 80. Okay. And it's moving. So that means like in most of the cases, if you check for every month, like you look through all those values, the 80% of the values at that moment, it's like forecasted as this one.
So can you show the pointer for me?
Yeah. Okay, and type is one. And,
Can we pass the multiple variables like an attribute?
Yes, you can. I'm gonna show you next one. So, which is about the multiple values. So we're gonna, just this worksheet, I'm gonna show you after this exercise. And you actually will see much better performance with multiple one. Yes, yes, we should. Yeah, so take a break. I come back with some fresh. I'll